All right, so in this video, we are going to be talking kind of about two big things. The first thing is kind of what is a function and something known as function notation. Now, throughout this video, and you can be taking notes in a notebook, but more importantly, we should be adding a few things to our toolkit. So don't forget, it's that pink toolkit we got the other day and looks on the front side like this, okay? So again, if you need a little bit more space, feel free to use your notebook. Okay, so one of the biggest things that we first need to address is what is a function, okay? It's a very important question in our math journey. So in your toolkit, right, I would like you to write down this definition of what a function is. It is a relationship between inputs and outputs is called a function when there is at most one output for any input. So if you need to pause the video now to copy that down, please do so. Okay. Another way that we could describe this is um, we can say for each input there is only one output. Okay, so basically what this means is that a function is predictable. So we know that something is always going to happen. So we like to think of functions as machines. Is your machine always going to work? Okay, so let me show you kind of an example of what I mean by that. So let's take a look at, can you predict the output? And if you can, it's a function. So you don't need to copy anything down. I just want you to kind of pay attention. So this is the question that I want you to ask yourself. Can you predict the output? If you can, you say yes, then we get to say that something is a function. If you cannot predict the output, then we get to say not a function. Okay? So again, predictability, and it has to work 100% of the time. Okay? So again, we'll just do a little practice rounds. This will make some more sense when we look at, tables and graphs. But again, here's our machine. So again, we have Blast soda, we got some Slurp, we got a lemon twister, and we have a Diet Slurp. Okay, so if I press the Blast button, right, where I put a little check mark, I'm going to tell you that every time you press the Blast button, Blast comes out, right? So it doesn't matter if I press this button or this button, Blast is going to come out. So if I go to this machine 4 days in a row and I press both of these buttons, I'm going to get a Blast button. If I go for the 5th day in a row, right, and I press one of these two buttons, what do you predict is going to pop out? So in your head, hopefully you said Blast. I predict Blast is going to come out, and you'd be correct because it's shown a pattern that we can say that each time I press the button, it's gonna pop out. Okay. What happens if I press this Blast button and sometimes I get Blast, right? So one time I get Blast, and then another time I get Slurp, right? So sometimes I get Blast, sometimes I get Slurp. So again, I keep pressing this button. Sometimes I get Blast, sometimes I get Slurp, right? So let's just say the first day I get B for Blast. The second day I also get Blast. The third day, though, I got Slurp, okay? The fourth day, I'm back to Blast, right? B for Blast. Can you predict 100% that you can guess what the 5th day is going to be? So again, take a moment, think about that. First day was Blast, second day was Blast, third day was Slurp, fourth day was Blast. Can you really predict what the fifth day is going to be 100% certain? And the answer is no. We have no idea. It could be blast, right? Because we've seen that 3 out of 4 times, or it could have been slurp, okay, based on what we've seen. So again, this would be kind of not a function. So again, I want you to be thinking about function means that your machine is working properly. You can always predict it. Okay, if it's not working and you can't predict it 100% of the time, we get to say not a function. Okay, so let's see what this looks like in terms of a table, right, or graph. Okay, so function or not a function. Okay, so let's take a look at number 1. All right, so number 1. Again, here's a little candy machine. So if you press 1, it looks like I could get a Stix, right? Generic for Twix. If I press 1 again, I also get a Stix. If I press 2, I get M&Ns. If I press 4, I also get M&Ns. And then if I press 2 again, I get duds. And I press 3, I get duds. So take a moment. I want you to think, is this a function or not? And why do we think that? Okay. So hopefully what you thought of is that this one is not a function. And the reason why it's not a function is because notice that your button number, that's your input, right? So this is your input right here. And then this is your output, is the type of candy that you're going to get. So if you press the button 2, you don't know if you're going to get the M&Ns or if you're going to get the duds. So you get 2 different outputs. So because of this, this would be considered not a function. Okay. Again, this is with candy. Sometimes makes it challenging. So let's take a look at the other 2 that are just tables. Okay. So again, remember the definition for what a function is. If we go back to our toolkit, we said where there is at most 1 output for every input, aka for each input there's only 1 output. Right? So we wrote that down in our toolkit. So if I come over here and I want to predict what number 2 is going to be, do we think it is a function or not a function? Kind of make your prediction in your head. Give you 30 seconds to think about it. If you need longer, pause the video. Okay. So the first question you should ask yourself is, do any of these inputs repeat? So I only see 7 once, I only see -2 once, 0, 4, 9. All of your inputs only repeat 1 time. So that means each input has only 1 output. So this would be considered a function. Again, each input has only 1 output. All right. So really be looking for, do we see more than 1 input? And then that would kind of tell us if something's going to be a function or not. Again, it's only based on what we see. All right, so let's do one more. So look at the last one right here, number 3. Again, make a suggestion, make a prediction. Is this going to be a function or not? Does each input have 1 specific output? Give you guys about 15 seconds to think about that. All right. So hopefully this time you notice that the input number 2 is repeated twice, and it's repeated with a different number each time. So one time I get 2, I plug in a 2, I'll get a 9. Sometimes I'll plug in 2 and I'll get -8. So that means I have 2 different outputs. So this would be considered not a function. Okay, now on your toolkit, there is a place to put examples of functions and not a function. I definitely recommend putting these two things into your toolkit, right? So put them directly under what is an example of a function and what is not an example of a function. Again, if you need to pause the video, please do so. All right, so how can I see this maybe in a graph, right? So we can see them in a table. Let's see it in a graph, okay? So again, remember one input has one specific output, things like that, okay? So let's take a look at some of these graphs. So this one's supposed to be 4, 5, and this one's supposed to be 6. So I'll put a little 6 here. Okay, now I want you to look at these three graphs and I want you to make a prediction. Which one do we think is not a function? Right? And again, be thinking about this in your head. Why do we think it's not a function? One of these graphs that we're looking at is not a function. So again, take 15 seconds to kind of think about that. All right. So this one right here is not a function. And the reason why it's not a function, okay, is that we can see that if I input, let's just say our input is 0, right? So let's just say our input is 0, right? What could some outputs be? Well, I see that an output would be 0. I see that an output is probably, if that's 1 and that's 2, I don't know, probably 0 point, I don't know, 45. Let's just make it up, right? 1, 2, so it's a little bit more than 2, so maybe it's 2.3, 2.3, I don't know. I could also go negative, so maybe it's negative 0.45. If this, or no, not 0.45, that wouldn't work. We get the idea. So this would be a negative 1 point, let's just say 4. 2, 3, so maybe negative 3.2. So notice that one input has 1, 2, 3, 4, 5 different outputs. So this clearly would not be a function. Okay, so again, you can add this example to your toolkit of not a function. Okay, which means that the other two that are up here are actually functions. So this one is a function and this one is also a function. So notice that the inputs, right, -3 only has one output, happens to be 1. -2 only has one output. -1 only has one output. 1, 2, and 3. Okay, and then this, just a line, right, positive slope, which we'll talk about in our next chapter. Again, it looks like for every input, there's only one output. So again, try adding 4 into your toolkit. Hopefully there's a little bit, some more space. Definitely add number 5 into your toolkit, and you can just add one of these into your toolkit. If you want to add them both, that's fine, but just one is perfectly fine. All right, now don't feel that you need to master this topic right now. We're going to be doing that over the next couple of weeks, right, and months and things like that. Okay, so now that we kind of have an idea of what a function is, let's talk about function notation because that's going to be huge. Okay, so function notation, I want you to find the box in your toolkit that is called function notation, and I want you to copy this down. This is what function notation is all about. Okay, your f is the name of the function. So name of the function. You can name your function anything. Most commonly, we see f of x. Sometimes we see g of x. So again, the g part is the name. The g, the f, this has nothing to do with multiplication. It's just a name, right? You could put a heart in front of it. It's perfectly fine. Okay? Now, this is where sometimes it gets confusing, right? This x right here, right, is your input, right? It's what you're plugging into your function. So again, this x right here is your input. And I'm going to show you examples, so don't stress out too much quite yet. Okay, so the x is usually the input. Again, that could be any letter. We just happen to use the x. Now, when you put them all together, right, all together, this f of x all together is what's known as your output, right? Or this g of x all together, when we put it all together, this is what's known as your output. Okay. So go ahead and make sure you have this copied down into your box, known as function notation. Okay. I also want you to add. I also want you to add this. So when you see f of x, this is, and you guys keep hearing me say this, what I'm saying is f of x. Okay, and then this one would be the g of x. Okay, so it's very specific language. Okay, you can kind of think of function notation as a fancy way of putting the letter y. Okay, so this would be the same thing as saying your output, or aka your y value. If you have a little bit more room in your box, great. If not, you can write this off to the side of your function notation. So I want to make sure that we have this, okay? So I want you to think of an equation. So I'm going to say, you know, y is equal to, I'll just say 3x minus 1, okay? And if I wanted you to input, and I said I want you to, here's an equation, I want you to input when x is equal to 3. So that would be the problem. Basically what you would do is you would say y is equal to 3, and then you would multiply the 3 in for x, and then minus 1. You would say y is equal to 9 minus 1, so y was equal to the number 8. Okay, so again, think of this as your input, and then this is your output, right? We get a very specific 8. Let me write my 8 a little bit better. Okay, so I know most of you guys could probably do that sort of operation. So what makes function notation different is just the way we set it up. So instead of the letter y, we say f of x is equal to, and then I say 3x minus 1. And so I want to know what happens when x is equal to the number 3. So essentially, everywhere you see the letter x, you're plugging in that 3. So again, I'm going to try to color coordinate it for you guys. So we would say f of, and then I'd plug in the number 3 first off. And then I would say 3 times 3, close that off, minus 1. Again, remember, f is just a name, so I'm focusing purely on the right side. So 3 times 3 gives me 9, and 9 minus 1 gives me 8. The only difference is my answer. Notice that my answer has both the input and the output all together. Okay, so notice that my 3 is my input, and notice that the 8 that I wrote is my output. So that's the great thing about function notation, is that we can kind of see those input and output together, versus when it's just y and x, we have to go looking for our input and our output, so to speak. Okay, so let's go ahead and add some more examples into your toolkit. Let's start off with this one. So find the box that says function notation solve for f of x. Okay, so this would be kind of some of your examples. So you might get an example that looks like this, where I'm going to say f of x is equal to negative 2x plus 4, and then I'm going to say x is equal to negative 3, right? So what that basically means is I know what x is, I just don't know what my f of x is, right? So when I plug it in, I'm going to say f of negative 3. So again, everywhere I see an x, I'm going to plug in the negative 3. Then this will be negative 2 times negative 3 plus 4. And then I solve for this. So negative 2 and negative 3, that's going to give me a positive 6. And positive 6 plus 4 gives me 10. So my f of negative 3 was equal to 10. Okay. We could see it in a different problem. Let me try this again. So again, think about it. Let me draw a little picture. Pretend that this is like my little machine, right? So here's a little machine, and I don't know. I'm a horrible drawer. This is why I'm not Miss Quimming and cannot draw things. So again, let me just come up with a new function. So I'm going to say f of x is equal to, I don't know, 3x minus 2. Yeah. And I'm going to say, let's plug in when x is equal to 1, right? And I want to know what is f of x? Question mark. Okay, so again, what this means is I'm going to plug it into this little machine. So that means everywhere I see an x, I get to plug in the number 1. So again, another little visual for you guys. So f of 1 is equal to 3 to the power 1 minus 2. So 3 to the power 1 is just 3. 3 minus 2 gives me 1. So my answer, f of 1, also happens to be the number 1. So again, remember, the f is just the name of the function. What's in parentheses is the input, and then what it's all equal to is the output. Okay. Now, what happens if we need to actually solve for x? So let me show you another example. So find the box in your toolkit, and we'll put 2 examples here. So what happens if we have something that looks like this? Okay. I have f of x is equal to, I don't know, 5x plus 2, and I give you that f of x is equal to the number 3. Okay, so basically what this question is doing, if I kind of draw backwards machine, again, do not judge me on my drawing. So again, here's my function, f of x, 5x plus 2. I get my output as f of x is equal to 3. So I don't know what my input is, but I know what my output is. It's 3. Okay, so basically what this is telling you is that you are going to replace, right, everywhere you see f of x with the number 3. So you're going to replace all of that with this, right? So you get to replace that. So what does that look like? It looks like this. So again, I don't expect you guys to draw my little machine onto your toolkit unless you want to. So we would say 3 is equal to 5x plus 2, and then notice that I'm solving for x. So minus 2 to both sides, so minus 2. 1 is equal to 5x, divide by 5, and I get 1/5 as an answer. So I get my answer. And if I wanted to, what I could do is I could actually write this as f of 1/5 is equal to 3. I could totally do that. Or I could just leave the answer the way that I boxed it, so to speak. Okay. Oops. Sorry about that. Went too far. All right. Sorry, don't know what happened right there. Let's try one more example so you have 2 examples into your toolkit at this point. So let's just go f of x is equal to negative x plus 7, and I'm going to say f of x is equal to negative 13. All right, make this up as I go. So what this basically means is, again, I'm going to replace all of the negative 3 with this whole thing, f of x. So this will become negative 13 is equal to negative x plus 7. I'm going to subtract 7 to both sides. Negative 20 is equal to negative x. Divide by just negative 1, and I get x is equal to the number 20. So again, this is a perfectly acceptable answer. Or if we wanted to write it in function notation, we could say f of 20 would eventually give us that negative 13. Either way is perfectly fine. Okay. So we talked about function, what is a function? We've now talked about what makes function notation, okay? So again, I don't expect you guys to master this by the end of this video, but we're just starting to get the idea and we'll get some extra practice with it.